webinar series. Thank you for joining us. This webinar will be recorded and housed on FCICA's educational portal. All attendees will receive a follow-up email with the recording within 24 hours. Audio for today's event will be broadcasted through your computer speakers. Be sure they are turned on and the volume turned up. All participants have been placed on mute. If at any time you would like to ask a question, please use the question feature. Only the staff will see your questions. And an announcement to our SIM attendees, if you have attended this live webinar, one CEU will be entered on your behalf, provided full attendance. Please note the system records your attendance time and participation level. This month, we have a great lineup of webinars. Next week, October 9th, is Dead Level Floors. Learn how to go from flat to smooth, from flat and smooth to dead level. On October 16th is Proven Tips to Save Time and Money for the Tile and Stone Installations with Mapei Ultra Care. And on Tuesday, October 21st, is Dry Adhesive Technologies for Flooring Installation. Registration is also open for 2 days to SIM, Aliquippa, Pennsylvania, taking place Wednesday and Thursday, November 5th and 6th, and a regional meeting in Aliquippa on Friday, November 7th. We encourage your attendance and engagement with FCICA via these educational opportunities. These events will be included in the post-webinar follow-up email, or you can visit fcica.com under events where you will find our full listing of webinars and events. Thank you for joining us today for Safer, Simpler Moisture Control with Vapor Band Primer W. We are pleased to introduce our speakers, Rizzo and Nicole Gay. Joe is the Director of Sales for Concrete and Substrate Preparation at LATICRETE. He leads the efforts of the US and Canadian teams in the sales of surface preparation, moisture control, and the SuperCap network of mobile pump trucks for high volume, rapid delivery of self-leveling underlayments and overlays. His perspective on flooring and concrete has been honed by the contractors and architects that he has had the privilege of working with for over 25 years. Nicole Gay is the Senior Product Manager for Concrete and Substrate Preparation at LATICRETE. With more than 15 years of experience in global product management and program leadership across various construction and building materials industries, Nicole has worked closely with contractors, distributors, and project teams to bring practical job site ready solutions to market. At LATICRETE, she focuses on helping contractors simplify substrate prep, improve efficiency, and get reliable results with the right products. Welcome, Joe and Nicole. I'm going to turn the controls over to you.
Thank you.
Thank you. Thank you for joining us today. We're going to take you through a webinar on Vapor Band Primer W. I'm going to pass it over to Joe for a quick overview.
Good morning or good afternoon to everyone, depending on where you are. Thank you for being here. We are truly appreciative of your participation and love the opportunity to be able to get in front of everyone. I am particularly excited today because this is my first joint webinar with Nicole, we've run through it, and we're happy to be here and presenting, and like I said, I'm excited to be working with Nicole on this and other things. Just a little bit of an overview of LATICRETE and who we are. We are a global company, family-owned, professionally managed. We have presence in over 100 countries where our materials have been used and sold, on all 7 continents. With almost 2,000 team members. In addition to that, in the United States and Canada and North America, we have an extensive network of our sales representatives as well as distribution where our products are stocked. So hopefully it should not be a challenge for anyone that wants to use LATICRETE items to be able to find them quickly and easily and get all the support that you need. One final note that I like to point out, we have been in business since 1956, very well known in the tile and stone installation industry, but have expanded greatly into many product groups since then, including concrete and substrate prep. And as I do like to say at times, our founder invented modern thinset, as it is known, polymer modified thinset that allowed cement-based glues for the installation of tile to be placed very thin. So next slide, please. And Nicole, back to you.
Thank you, Joe. I'm going to be introducing you to our newest innovation in moisture mitigation, Vapor Band Primer W. This is a water-based, ready-to-use primer and vapor barrier all in one. What this means for installers is fewer steps, so no separate primer, no mixing of A and B components, just open the pail, mix, and apply. It's engineered for a CSP of 1 to 3 concrete prep, and it also provides high performance protection at 100% relative humidity, 14 pH, and ember up to 25 pounds. That's industry leading coverage against the 3 biggest threats to flooring failures. With strong bond strength that ensures that substrate is truly ready for final flooring installations, including self-leveling underlayments. Simply put, Vapor Band Primer W delivers speed, safety, and simplicity. It can go anywhere an epoxy can go, while also saving contractors time, labor, and material costs. And now I'm going to pass it back to Joe for some technical information on moisture.
Thank you very much, Nicole. So our objective in this presentation is to take you full circle through the technical considerations of moisture, how Primer W and moisture mitigation in general can help with the installation of final flooring and make it possible in high moisture situations, talk a little bit about not just the product, but the market, and then sort of bring it back full circle so that we cover the problem and the solution for moisture as it affects flooring through a substrate. So the moisture that I'm referring to in the concrete slabs that are the substrates for final flooring can come from one of 2 places. When we talk about concrete, one of the main components is obviously water, which hydrates with cement. It does not only dry like other materials that have water in them. In the case of concrete, water and cement have a chemical reaction called hydration. But in order to make the concrete usable, we need more water than just the water that's reacting with the cement. So that is called the water of convenience. It's what gives the concrete its flowability. And that water of convenience remains in that mix as water and has to be released from the concrete itself. That can be problematic for final flooring systems depending on the glue and the floor itself, because the water is then released upwards through the slab. The good news is that it's in limited amount, it's in a knowable amount in elevated slabs, i.e. the only place that the water can come from in an elevated slab is from the water that's in the mix itself. And that may eventually dissipate. However, it is a problem if we're doing fast track construction, because it may take months for a concrete slab to let go of all its excess water. And that's a problem that needs to be solved. Now, if we have a slab on ground or a slab on grade, we have additional problems. And those additional problems are that we're not only worried about the water from the concrete itself, we are actually worried about water that's coming in from the ground, from a water table, from the groundwater itself, into and through the structure. So that water is a little bit different than the water of convenience, being that it's an external source. Any moisture readings that we take are only a snapshot in time. And we only know for that moment what we have as a water condition, which means at certain times of year or certain times of the day, depending on what the environmental conditions are, we may not get a true reading of the maximum potential of how much moisture can affect our final flooring. The other thing that water coming in from an external source from the ground is that it creates a hydrostatic pressure. So not only do we have the water vapor emitting through the slab, it's doing so at some level of positive pressure. Next slide, please. There are a number of ways that we measure the moisture content of concrete, and different ASTM tests that deal with them. One of the primary methods is measuring relative humidity. Relative humidity in a slab is a concept that not everyone understands. Essentially, it measures the amount of humidity in the air that's in the concrete itself. If we think of concrete as a very strong, very structured sponge, it kind of gives us a good analogy, because concrete itself, for the most part, is porous, which means that those pores have air, which means that that air has a certain amount of moisture in it, and that is what relative humidity is. It is measured by ASTM F2170, where essentially a hole is drilled, the core is taken in the concrete, and the probe that you see in the picture is dropped in and can measure quite accurately what the humidity is inside the air, inside the concrete. Modern, newer systems actually have remote broadcasting, where information is not only shown on the little screen of the probe, but can be broadcast to a computer or a phone or some other type of device with software that actually keeps trends and will show an analysis of what that moisture is doing over time, given the environmental conditions. Next slide, please. pH is something that is increasingly looked at as part of what creates a problem for final flooring. And there's an interesting juxtaposition with the pH of concrete, and where it's good and where it can have some negative effects. So pH is a measure of how much a material, without getting too deep into the chemistry of it, it's a measure of how acidic or how alkaline or basic a given material is. Concrete itself has a natural pH of 12. The higher the number, the more alkali the content, the more basic the material. So a strong acid is a low number, 1, 2, 3, so forth. Water, distilled water, which is neutral, and is neither acid nor base, has a reading of 7. Concrete reads about 12 or higher. And most flooring adhesives are only rated for a pH of 9 to 10. So we see a problem right there. I did mention there is a positive to the high pH of concrete, and that is that concrete is what is the structural system of a building or other type of structure that has steel rebar. Steel likes to have high pH because it will not rust under alkali conditions. But glues, and remember, we design buildings and we design concrete for the structure more than having it as a substrate for final flooring. One very important thing to mention about pH: if you have a bone dry slab, pH does not affect the final flooring glue at all, because moisture is the carrier that brings through the hydrogen ions that are described in our written description. So a dry slab without moisture will not have pH problems, but a wet one will. Next slide, please. And finally, we look at the rate of moisture emission. So we know what our relative humidity is, we know what our pH is, and we can also look at how much moisture is coming out of the slab at what rate. So that's more of a dynamic situation. And the particular test that looks at this has a cover or a cap which is glued down to the concrete, and that sample of calcium chloride that you see there will absorb the amount of water in a limited 1 square foot area. So we know how much moisture we're getting in how much time in a precision measurement by weighing that calcium chloride 72 hours after the test rig has been set up. So now we have a complete moisture and chemical picture of what's going on. Let's see how this affects our final flooring. Next slide, please. Sorry, I had to take a sip of water there. This is essentially what we're looking at. We have a concrete subfloor. By the way, quick note, most everybody knows this, but every once in a while we find some people that don't. The difference between a subfloor and a substrate. A subfloor is the complete flooring system underneath the final floor. So it'll include things like the slab itself, or if in a wood floor situation, the joists, everything that comprises the system is the subfloor. The substrate is simply the surface onto which the final flooring is being stuck on. So as we have moisture moving through our substrate, our subfloor coming up to our substrate, we're creating a chemical environment that is a wet, high alkaline moisture situation, which can affect our adhesive. And if we happen to be on grade, we are creating also hydrostatic pressure, which is mechanically pushing up onto the final floor itself. Next slide, please. The effects that we have are fairly simple. We can have a chemical breakdown of the adhesive itself. And additionally, even if we don't have a chemical breakdown of the adhesive, we can actually have flooring that pops because of the mechanical pressure created by the hydrostatic effect of the water coming through. Next, please. Here's some real world effects, and I hope that you guys haven't seen anything as severe as what we're looking at here. These are all types of resilient flooring in different real world applications. And right now, by looking at it, we can tell that we definitely have some type of bond and adhesion problem, which is not a mild but a rather serious one. And with, you know, when we start looking at something so severe, we can tell that we may have a combination of factors that is affecting this complete failure of the flooring system. In the middle picture with the gray floor, you can actually see that with the water itself that's coming through the floor, we're also getting efflorescence, which we'll talk about a little later on. And of course, in the picture with the tan colored floor, you can see the effect on the seams of the flooring. So these problems caused by moisture can be rather devastating. By the way, I do want to make a very positive mention on a technological advancement that's been happening in the industry over the last few years, and that is moisture insensitive flooring glues. So there are glues out there now that can take a significant amount of moisture, depending on how they're rated, and they're generally rated by relative humidity, without having the chemical breakdown that I've discussed. So that is a very positive development. I would like to point out that those types of glues are pass-through systems. They actually allow the moisture to come through them in the same way that self-leveling underlayment can take 100% relative humidity, but it does not prevent that humidity from passing through our final flooring. So these glues that are up to 100% relative humidity rated will not protect the final flooring. So if you're talking about a wood floor, you can still have staining and warping. If you're talking about carpeting, you can have the moisture pass through into the space. Resilient flooring does best with these types with these types of glues. And the glues as pass-throughs are not rated for hydrostatic pressure, which is what we would see on a slab on grade. So I would like to point that out because the glue and the moisture situation and the moisture mitigation system all work hand in hand together. Next slide, please. Here we definitely see a manifestation of moisture coming through, and this is a slab on grade, and this is actually water. This isn't just vapor. So one thing that should be pointed out is that we can be looking at two different forms. We can with vapor, we're talking about a form of moisture that is not nearly as concentrated as liquid water. This is a sign of hydrostatic pressure on a slab on grade. Next slide, please. Here we see what the pH effect is on the glues. It turns them soft, mushy, gooey. So we see the destruction of the glue, and we also see the minerals and whatever else is coming up through the concrete itself. Next slide, please. Okay, so I've mentioned efflorescence, and efflorescence is not a 1990s goth metal band, which is very near and dear to my wife's heart, and my daughter's as well. That would be evanescence. Efflorescence is the presence of minerals and salts inside concrete, which would stay inside the concrete, except if there's moisture coming up through the slab, which will not only have our chemical pH effect, but will also push these salts to the surface of the concrete and possibly into and through the glue of our final flooring and through the final flooring itself. Next slide, please. Okay, in the past, we generally didn't think of moisture mitigation systems as a primary need to have use of underneath a tile floor. And the reason for that is because the cement-based mortar and thin-set systems do an excellent job at withstanding moisture and bonding despite moisture coming through the substrate. However, what we do see is efflorescence and moisture coming up through the grout joints, causing a very ugly effect. An additional tile application where moisture mitigation is looking to be very beneficial is in very large tile applications, large format tile with thin grout joints. One of the reasons that we considered in the past that moisture wasn't a threat to tile installation systems is because the moisture vapor could pass through the grout joint. But as we've all seen, tile is getting larger and larger and less pervious. So water can't go through the tile itself. It can only go through the grout joint, but the tile is getting larger, the grout joint is getting smaller, so there are fewer places for moisture to come through, which on a slab on grade can cause a hydrostatic pressure situation, which is severe enough to have a potential failure in bond on the floor. So that in summary is are the different effects of what moisture can do. And one final little technical point: when water comes up or moisture vapor comes up through the slab itself, we refer to that as negative side water exposure or water pressure, as opposed to positive side, which is what happens when you spill water over the top of something. Next slide. I believe we're going back to Nicole, so you guys get a break from my harsh voice onto someone who is more pleasant and smarter than I am.
Thank you, Joe. Now I'm going to take you through a bit about the market, features and benefits, trends that we're seeing, things like that. So the moisture mitigation market is growing steadily at 6 to 8% per year. North America holds the largest share, driven by high construction volume and specification-driven projects. The biggest growth, excuse me, is in the healthcare, education, government, and data centers. Sectors where strict flooring specifications and reliable performance are absolutely essential. Why is moisture mitigation so important? Flooring failures due to moisture are among the most common and costly callbacks in the industry. Contractors and owners now recognize that vapor barrier and primers are not just add-ons, they're insurance against failure. Excuse me, and that's exactly what Vapor Ban Primer W is. It's a low-cost insurance policy. We're also seeing more fast-track construction schedules, which means slabs don't have enough time to cure naturally. Add to that stricter warranty demands, it's clear why products like Vapor Ban Primer W are gaining attention. From a contractor standpoint, this is also provides the ability to grow your offering. Some of the features and benefits of Vapor Ban Primer W are protection up to 100% relative humidity. It's a ready-to-use water-based formula, no mixing of A and B components, safer to handle, less mess, and reduces job site hazards, has strong bond strength that supports self-leveling underlayments, full system compatibility with warranties up to 25 years, and it's safer, faster, and simpler for installers while protecting the long-term performance of the floor. Vapor Ban Primer W is ideal for moisture and pH-sensitive floor coverings, both slab on grade and elevated slabs. It's packaged in 5-gallon pails with 36 pails per pallet. Application does require 2 coats, a base coat and a secondary coat, with an hour to 2 hours of cure time between each, depending on site conditions. You can use a wet film gauge to confirm 8 to 10 mils per coat, and the average coverage is 88 to 100 square feet per gallon across both coats. LATICRETE stands behind the product with a comprehensive warranty package. Warranties range from 1 year for product warranties to system warranties of 1, 5, 10, and even 25 years when used with the LATICRETE system. This provides peace of mind for contractors, specifiers, and building owners alike. Vapor Ban Primer W is part of a broader LATICRETE moisture mitigation portfolio. Alongside epoxy-based solutions like Vapor Ban E and Vapor Ban ER, we are now offering a full range of options. Whether your priority is speed, safety, or maximum performance, LATICRETE has the moisture control solution that fits your project needs. At LATICRETE, we know that launching a product is only part of the story. Making sure contractors feel confident using it is just as important. That's why we provide a full range of educational resources. You'll find brochures, safety data sheets, and warranty information to support specifications and job site use. We're also developing a dedicated LATICRETE University module for online learning so teams can get up to speed anytime, anywhere. Instructional videos are available on our YouTube and also in Inside Track, covering both product overviews and step-by-step application guidance. And finally, we continue to engage through industry webinars like today with FCICA, as well as our upcoming events such as NWFA later this month. All of these resources are designed to make sure you and your teams can use Vapor Ban Primer W with confidence and success. Thank you. We'll now open it up for questions.
Great, thank you very much. So if anyone in the audience has any questions, please enter them into the question feature on the screen. And we do have one to start with. Please expand on the differences between moisture and elevated slabs versus slab on grade. What do you mean it's a snapshot in time?
Okay, thank you for asking for that clarification. It all has to do with the source of the water. The elevated slab only has water internally coming up through it, and it is you can get a fairly accurate description, a very accurate description with the testing that I refer to as exactly what our moisture situation is. And it's not going to get any worse than that because there is no external source of water. So when we're looking at the RH of an elevated slab, short of somebody leaving windows open and the slab gets rained on or somebody pours water over it from the top, but there are no other sources than the moisture which is in the concrete slab itself. And so the reading that we get is the worst that it's going to be. Non-elevated slabs on ground have external water, so we may have a relative humidity reading of 50% today and 98% tomorrow, depending on what the environmental conditions are. Even if the building is totally enclosed and acclimated, we don't know what's going on in a basement by simply having a reading on October 2nd. We don't know what's going to happen in December, on December 2nd or June 2nd. Hopefully that answered your question.
Yeah, we have quite a few more that have come in. One is, what is the PERMS value of the vapor ban according to ASTM E96?
Less than 0.01. So it meets the requirements that have been set as the standards for the industry. So in effect, it is every bit as effective and useful as the most stringent epoxy system. That's a great question.
Okay, great. Can this be used over a chemical abated slab? If not, what do you recommend?
Well, if the slab is truly abated, so I'm assuming that we're talking about a slab that had some type of asbestos glue on it, and it has been abated, and that removal is total. There's no reason that I can see that it can't be used. If the abatement is not complete, there is testing that can be done to look and see if the product would be suitable. I will say this: and as far as I know, most manufacturers of moisture mitigation systems do not claim to encapsulate a slab. So that is not something that we would. If the slab is still hot, which is the common way of referring to a slab that still has asbestos on it. If the slab is hot, we would very kindly bow out and say that we are not an asbestos abatement system. But if the slab is abated, chances are that the product can be used.
Okay, great. Does your product warranty the decorative floor covering itself or just the bond of adhesive to your product?
If we have a project warranty, we can do custom warranties. So if it is a decorative floor, we will have provision for the project itself. I will say one thing with decorative floors, and that is if someone is using an overlay system, we still recommend the use of a sand broadcast epoxy as a primer for that. And if it's a moisture condition, we would recommend a moisture mitigating epoxy like our Vapor Ban E or our Vapor Ban Primer ER. And the reason for that is because even though Primer W is an excellent bonding agent as part of its primer function, and it makes an excellent primer for underlayments, for overlays, you're not only looking for that enhanced bond, you're looking for a 3D, a three-dimensional lockdown that can only be provided by broadcasting sand into an epoxy and creating a profile. We want that profile as well as the bond strength for those types of systems. So that would definitely be something that we would closely look at to make sure that the right priming system is used for a decorative overlay.
Okay. Is it likely that a primer would be required before applying an adhesive to vapor band?
It is likely that if the adhesive is a water-based adhesive that has to release moisture, and not all flooring adhesives are. You have certain like dual component adhesives that are chemically reacting, but the vast majority of flooring adhesives are still moisture-based that actually release their moisture into the substrate. So you wouldn't need a primer. What you would need is a cement-based coat of either a skim coat or a 1/8 or less inch of self-leveling underlayment. And what that does is it provides that cementitious layer which will absorb the water from the glue so that the glue works the way it's supposed to. So technically it's not a primer, but there is a cement-based layer that is required for those types of glues.
Okay. Is this product only applicable for self-leveling, or can adhesives be applied directly?
So similar
Yeah.
question to what we had before. By the way, if it is a type of adhesive that doesn't need to release moisture, I do believe that it can go directly over the top of the primer W. But you know what? We would look at it on a case by case, just because there's so many different types of glues that are out there.
Okay. Does this product meet ASTM F3513 for resilient flooring?
It meets all the performance characteristics and requirements of that specification. And I don't remember if that's the specific spec which names that the moisture that it's a resinous or epoxy moisture mitigation system. There is one of the main specs, and maybe that one says specifically that this specification covers epoxy based. So obviously this is not an epoxy based system. It is a single component water based system with all the positive things that you get from that, i.e. economical, easy to use, less surface prep requirement. It has all those, but if somebody is looking at the words, on a specification that say an epoxy moisture mitigation system will be required, it is not an epoxy. I believe ASTM is currently developing or has developed specifications that now allow for the language and the use of non-epoxy, non-dual component products.
Great. What is the required prep before applying your product? CSP 123 must be diamond grind?
You can do a CSP1, depending on the concrete itself, that may or may not require a diamond grind. Essentially, what we're looking for with Primer W is to open up the porosity just a little bit, not as much as you would need to with epoxies, and essentially a clean surface. And what we found, and I think every manufacturer can attest to this, that sometimes in order to get a clean concrete, you can't just clean it. You have to do some type of mechanical profiling. And that could just be, again, depending on the concrete, sanding itself for a light diamond grind or a light brush blast. But any type of mechanical means like that is, for this product, is very beneficial because you get to a clean concrete, as well as the tiniest bit of profile that's required by CSP1.
And how does it compare with other products that contain polyurethane silane based or acrylic single part?
So without getting into the chemistry of the product, the performance of the product is one that it meets all the stringent requirements for final flooring, 0.01 or less perm, reduction of MVER from 25 pounds or up to 25 pounds down to 3 pounds, which is the acceptable level. And it will take 100% relative humidity. So it meets the most stringent, toughest specifications, regardless of chemistry.
Okay, can this be rolled on direct over a burnished slab?
Well, you'd have to get that burnished slab to a CSP1 condition. I'll make a general statement, and that general statement is that even with low surface prep products, you will generally get better bond and better adhesion when there is some type of profile that's made. So it's not to say that we wouldn't stick to a burnished slab, but we will definitely stick better if that burnished slab is brought to a CSP1.
Okay, does it self-level any concerns around telegramming?
It should not. It should not telegraph. The way we recommend putting it down is in order to get your 8 to 10 mil thickness, you can put it down with a notched squeegee to get the proper coverage. And then the recommendation is to back roll it with a medium nap roller. So there should be no telegraphing, because once you hit it with the roller, you'll flatten it out, and you won't see ridges on a thin vinyl or other type of resilient floor. And I know that some of these flooring systems, you can get a resilient floor that's as thin as 2 millimeters that'll telegraph pretty much anything. But with back rolling, we avoid that completely.
Okay, primarily concerned with chemicals used to abate and the combined impact with high moisture. Is bond still warranted?
We'd have to look and see what those chemicals are to give an answer that is, an all-encompassing answer would be a dangerous thing, because as soon as I think that I've covered the different mechanisms for cleaning a floor and abating a floor, there's something else, another new technology, another general statement, which is always useful, is to do a mock-up, right? If we're dealing with chemicals that we may continue having an effect on the concrete after the subsequent layers are placed on it, because that's a chance that you're always taking with chemicals, right? If the chemical will dissolve or somehow react with what's on that concrete, there's nothing to say that if the cleaning afterwards that's done, that there isn't the presence of that chemical, and that it doesn't continue to act on the concrete itself or the subsequent layers. So I would strongly recommend looking at this on a case by case, doing a mock-up. And I mean, and there are cases that we know what the results are and that they'll be positive. So yeah, there is a distinct possibility that there are chemical systems which are totally then cleaned off the concrete that may not cause a reason of concern or a reason not to warrant the system. But we'd like to look at it individually.
What about the plastic that is supposed to be in the slab during construction?
The vapor barrier. So vapor barriers are poly sheets that I believe are 6 millimeters thick, and they do a good job up to a certain extent of preventing moisture that is in the ground from passing through and into and through the slab. Here's the problem with plastic sheeting. On brand new construction, it can rip. So we may have areas of water ingression coming up through the moisture barrier, the polyethylene sheet. The other thing that happens is, like so many organic materials, and plastic is a material that has carbon in it, and I use the old chemical and chemical engineering definition of an organic material, or something that has a carbon-based skeleton. There is deterioration over time, there is drying, there is brittling, there is a minimization of what they do. So they can either tear or pretty much not exist after about 10, 15, 20 years, depending on the sheet itself. So if we have an existing structure, we may no longer, that's been in place for a while, and here we're talking about a slab on grade, we no longer have the protection from that sheet. So that's kind of the juxtaposition of a slab on ground between what a moisture barrier underneath the slab would do versus what a moisture mitigation system like Primer W does.
Okay. Do you have to meet ASTM F3191 to warrant bond?
I am not sure. I'd have to look up that spec because I don't know by memory which one 3191 is, or if I know it, it's not coming to me right this very second. But in general, in order to make warranty, if you meet the stipulations that we set forth in our data sheet, and 3191 is not mentioned specifically in the data sheet, but if it's a clean, solid slab with the CSP1, it qualifies for the warranty. By the way, the Primer W can also go over exterior grade plywood and oriented strand board. The question comes up, well, why would you need a moisture mitigation system over the top of wood? And that's frankly one that when I first heard it, I wasn't sure either. But there is a possibility of moisture in the wood itself, or maybe pass through moisture from a layer below. So if for whatever reason you've got wood over a concrete slab, or you've got moisture in the wood itself, Primer W can go over the top of the types of wood subfloors, substrates that I just mentioned.
Okay, they said F3191 is floor prep process and requirements.
So we don't call specifically for the spec, but I can tell you that if it does meet 3191, that will more than likely cover our requirements in our data sheets. So if that answers the question.
Yeah. How do you validate the proper membrane thickness was applied?
So when applying it, using a notched squeegee should get you pretty close, but then you could use a film thickness gauge, and we have posted in different places the proper way to use a film thickness gauge. It's essentially it's a piece of metal or plastic the size of a credit card that has drawn little bars of various mil thicknesses, and you can put the edge of that card into your coating, and whichever bar is the largest one that gets completely covered by the wet coating is what your thickness of your coating is. And anyone who's interested can contact us, and I could give you some links where we have how to use the film thickness gauge.
Okay, and the follow-up question to that was, after product is dry?
After product is dry, is not something that we typically recommend. There's no need for it. If it goes down at the proper wet mill thickness, it will give the protection that's required. If the question is referring to, we haven't done measurements on the wet film, there's a problem, and now the material itself is dry, it's that has to be destructive testing. So you have to remove your final flooring, obviously, and remove a piece of the membrane, and hopefully that may be achievable. That may be a challenge because it's pretty well bonded to the concrete, but really the only way to do it is to get a piece of it off the floor and then measure the thickness with calipers, and we can give you a corresponding dry thickness. I'm not sure if the dry thickness will be the exact same as the wet thickness. I doubt it, being that it starts as a liquid and then it loses something. Obviously, it solidifies. So we can give you correspondence to what the dry is, but that's not the typical way of doing it.
Okay. And there was a question, can this be used on gypcrete?
In general, moisture mitigation systems should not be used over the top of self-leveling, period, regardless whether it's gypcrete or cement-based. Now, there are certain exceptions, but gypcrete itself is particularly susceptible to being destroyed by moisture, right? One of the properties of gypsum is that it dissolves in water. Gypcrete actually does not hydrate in the same way a cement-based self-leveling would. The water in the gypcrete evaporates, and that's how the dry layer is. So if you were to trap moisture underneath a moisture mitigation system with gypcrete being our substrate, there is a distinct possibility that gypcrete will be destroyed, dissolved, go mushy, any number of negative things. So it should not be done.
Okay. And can you use this band primer for industrial use as well? I mean, band under specific self-leveler to support forklift traffic. Would the bond be enough?
So if we're not using an underlayment, a self-leveling underlayment, but we're using a self-leveling cement-based overlay system, like the ones that we make are called NXT level SP, NXT level DL, in an industrial or commercial setting, where you have forklift traffic and so forth, that goes back to the general recommendation that we make, that these types of overlays should be placed with sand broadcast epoxy, not only for the bond, but for that three-dimensional locking effect that the profile that is created with the sand will give you. So yeah, no, don't do it.
Okay, great. I think that answered all of our questions. Is there anything else you want to add at the end? I know you got a lot of questions here at the end, Joe.
It's been a while, I think, since I've personally seen on a webinar quite as many questions and really targeted great questions. So yeah, expression of appreciation is the last thing that I would have to say. Thank you.
Great. Well, thank you so much for joining us for the webinar today, Joe and Nicole. We appreciate you being here and answering these questions and sharing about the product with us. So that'll be the end of the webinar. Just a reminder to everyone, you'll receive an email from GoToWebinar with this recording in the next 24 hours. So you can, watch it again or share it. And just a reminder, in the chat is the event listings for all of the FCICA upcoming events if you wanted to register and join us for any of our future events. Thank you and enjoy the rest of your Thursday.
CJ, thank you, and thank FCICA and Christine for the wonderful work that you guys do for the industry and putting these webinars together and getting so much information passed along to everyone in the industry. That awesome work. Thanks.
Yes, thank you. Talk to you soon, everyone. Bye.
Bye-bye, everyone.
Thank you.